last thing is geometry, because in commercial buildings, generally, they're simpler. Simpler is cheaper, simpler is easier. And the other thing is that your skin to volume increases, so your ease of making it passive increases. I like to tell my sons, I am a passive house. I have worked for years to get the perfect passive meat sweater surrounding me, and it has been very successful. All right, so you know, so this is the thing that people always ask, right? And as soon as they ask me that question, I want to turn the discussion, because what they're really saying is, you know, if this is the passive house and this is the standard house, and this delta is what I say day one, they're really asking me not what the break-even point is, but how long before I've used up all my initial cost savings and how much value have I left on the table, right? Because you know that building's going to last an awful long time. So I don't want to talk about that. As soon as somebody talks about that in the commercial world, I switch them over to return on investment, and I talk about demonstrating. And so I show them how we can make a return on investment. So I wanted to just point out a few projects. And these are some of mine and some other folks. So here is, okay, this is Elm Hall. This is Hickory Hall. This is the one that was built in 2010 as 4-story modular, blah, blah, blah. It walks out on the backside. And this is Hickory Hall, that's built as passive house. So that was completed then. This one's under construction. We should be done in another few months. Just as a comparison, 117 beds for Hickory, Elm's 116. Size is 39,000 gross and 34,000 gross, so it's a little bigger. We're looking for passive house and LEED silver. I begged them not to do LEED, but I had to do it, and because this one they're shooting for LEED silver. What the budget, the actual cost, they paid $4.5 million for Elm. We paid $4.73 for Hickory. Predicted energy use was 42 kilobTUs per square foot per year, and we were predicting 16. And if you look at it, you know, there's not a lot of difference, right? The above grade walls, we bumped them a little bit. The roof was a little bit. The windows were the most significant jump here. We did a calculation. I did a lot of what ifs just for curiosity. And one of the things we did was when we modeled Elm Hall, we took Elm Hall, the only thing we did was replace the windows with passive house windows, and we saw a 25% drop in heating demand by doing that. So it was really an interesting. I said, look, if you all don't build passive house, at least buy the building. You know, so ventilation, they're just using raw outside air, and we're using the passive house compliant ERVs. We're using an integrated hydronic geothermal system, and they're using PTAPs. The heating load, our design heating load is 50,000 BTUs, and theirs was 570,000. So you can see right there. And then our installed heating capacity. This 142,000, that's because we included about 50% of our domestic hot water usage. In our soils, where we're using ground source, what we've learned over the last 20 years is you've got to balance your heat and cool loading over the year, because our soils tend to kind of, if you have an unbalanced situation, it will reduce the efficiency over the course of years, because our soils build heat and hold it. They're semi installative. So you know, we were finding we were having not enough heat to balance the cooling load, so we took about half of we needed about half to balance it out. And then so they have 818,000, that includes their heat. So this is why the economics work so well, right? So Hickory Hall, our design cooling load was 14 tons, and we installed 14 tons. In Elm Hall, their design cooling load was 32 tons, and they installed 68 tons. Right? That's why the economics work, right? Because the owner paid for double the tonnage they needed, and they're going to have, you know, half the life cycle out of those units, because they're going to all be working not to peak efficiency. They're all going to be short cycle because they're oversized. So just our energy performance, we're looking at about 74% current code, about 60% below Elm Hall. We started looking at, this is our initial modeling, we were looking at, you know, just loading, and we started saying, well, what is in this? And we started looking here, and we found that clothes washing, clothes drying was over half our load. And it took us a month to convince them to go from a 600 RPM washer to, we tried to get them to go to 1200 RPM, they ended up going to 1,000. but it took us over a month to convince them that it'd be less energy over time, it'd be less use on the the whole thing. So here's the investment, $230,000 investment. If we assume the U.S. average, what's your kilowatt hour rate here?
13.
13? So you guys are a little higher than the U.S. average, and the U.S. average from Energy Information Agency is 2%. We see that this curve is the actual yearly ROI, and this is a annualized, so that if you were to take whatever the savings were and bring it all the way back and amortize it. So you can see here, by year 40, and they have dorms on this campus that are over 100 years old, so we know they're going to be there 40 years, they're earning 19% back on that initial investment of $230,000. That's a hell of an annuity for a college, right? And you get in front of the financial guys and start showing them this, and it took me, okay, so the way let me tell you a little about the evolution of this, right? 4 years ago, I take my passive house training, and this group down in Roanoke had built a modular dorm for a local college, and they built it to Energy Star. So it was the modular factory. I knew somebody there. I knew somebody at the college, and I was just curious because, I mean, in my mind, I said, passive house makes really good sense for these large buildings. So I went to them. I said, "Can I borrow your plans?" And I'm not going to charge you anything. I just want to, have the plan. I'm just curious. I want to run this through, and I want to see what it would take to go to passive house and how much money difference it would cost, do I think, to build it for passive house. So I borrowed this set of plans, and I just went back and spent a bunch of evenings working on it, and I came up with about a 3% delta in cost to go to passive house, and it would save about 40% over Energy Star, is what my calculation showed. And so I thought, man, this is great news. So I went around for 4 years trying to sell a dorm to anybody that would listen, and nobody would listen. And then last November, and this is coming up next week, and we're having our local energy show. And last November, I was sitting at the energy show with my passive house booth, and trying to sell people passive house stuff. And this young man comes up to me and he goes, "Well, have you ever thought about building a passive house dorm?" I thought, "Oh, I thought about it." And we started getting along. But it turns out, and this is where the stars just all aligned, he was the energy manager for 2 colleges. There was a grant, his 3-year position. And one of the colleges had built a modular dorm with the company that I had borrowed the plans from 4 years ago. 2 years ago, that was the Elm Hall. And they were getting ready to build this new dorm, and they wanted to step it up. And they were getting ready to put in a $350,000 geothermal field to try to get better energy saving, which is about they're going to get 35% better energy saving. So what we did was, I said, well, get me in front of the people. And they got me in front of the folks, and I was able to convince them that this was the way to go, and because it was a less investment for more energy. So, and the fact that I had already worked with the modular company, and that they had a relationship and trusted the modular company, and that the modular company trusted me, made all those little stars align, which was just freaking lucky. So, and here's the best news. Elm Hall by square foot, $125 a square foot for Elm Hall. Hickory Hall, the passive house, $118.25.
Wow.
Now, if we save 50 to 60, I've modeled 60%. If I save 50%, and it's $5.575 cheaper, I mean, that we have the chance to change the way we build dorms, right? Because people are going to look at this, they're going to line up for these things. Okay, there's the Malcolm Rosenberg Center for Jewish Life. We're just about done with it. If anybody wants to go into a long story of frustration, I will tell you about the hood in this thing. But the building's just about done. 8,000 square foot, multi-use assembly, very complicated roof structure. But here's the return on investment. Here was $125,000 to go from what we were going to build to the passive house. Initial investment return was 10.3%. And this is for a nonprofit that's got a tiny little budget. So over time, in year 20, they're making 15% back on that $125,000 investment. That's going to impact their budget significantly, because their budget right now is less than $100,000 for operations. 18%. So what happened was they got a gift to build the building, but they didn't get a gift for operations. Okay? So, year 40, they're going to be making 22% on that small $125,000 investment. So they're going to be making, yes, Mark?
Can you just say again what the difference between those two curves are?
This is if you take the cumulative savings up to that year. So if you take whatever the cumulative savings and then average it back over the 20 years, what would that annualized rate be? So you know, if you had a fixed, you know, it's the difference between a fixed annuity and a variable annuity. So if you looked at it as a fixed annuity over time, this was 12.58%, but actually on that year you made 15%.
So it's a simple payback versus a ROI.
Well, it's ROI that's annualized versus ROI that's simple. You know, that's per year.
But the blue line is simple, and the
No, it's not. This is not simple. This is not simple.
That's-
This takes the total cumulative savings and then divides it by the number of years to give you what the annualized rate. So what we're saying is, if you stop right here in year one, you made 12.58% instead of 10.35%. Take your cumulative savings and divide it by the number of years. So in year 40, if you looked at year 40, they were basically making a flat line fixed annuity percentage over that year over there of 15.6%.
The lower one is net present value?
Not really net present value, but it's a sort of kind of net present value. It's a simpler form of net present value. Yeah, net present value I find, so what we find is very simple calculations of economics make sense to most people, and that when people get more sophisticated in their economics, they usually have their own assumptions they want to build into those models. And so what we do is when we start sitting down, like we had the West Hampton dormitory, they had a very specific way of analyzing life cycle costs for their buildings. So what we do is we sit down with a financial guy and say, give us your parameters and we'll build the model. Rather than us trying to, you know, make complicated net present value models that don't mean anything to most people, the people that actually mean something to usually have their own ways of thinking about it. So they want to have certain discount rates and certain, you know, I mean, the whole thing of financial future value is kind of mumbo jumbo anyway, in my opinion. You know, I mean, you're betting on stuff that's not really real. So delivered for $135 a square foot for the building, not including site, right? That's about what a building like that should cost in my area. Maybe a hair cheaper, actually. So the dental clinic. So what we did on the dental clinic was we assumed no savings of electrical and energy whatsoever, only savings of heating and cooling energy. Okay? Because when we started the process, we were still, because the prototype certification, what we did was we had to get a baseline. Luckily, this is a 30-year-old practice that's changing generations. So one doctor's already, his son's taken over, the next doctor's retiring, his daughter's coming in 2 years, and then the other guy, he's got about 10 more years to practice, but hopefully his son will come in and take his.
Could you explain prototype certification?
Prototype certification is working with PHI. They are doing a high process load building, so it's going to have more primary energy than 120 kilowatt hours per square meter allowed. So, but what we had to do was, and luckily it was a 30-year-old practice, they had all their equipment, so we spent about 3 months monitoring their existing equipment to get readings of what they were using already, so we had a baseline that we could work from. You know, and that was, so what we did was we said, forget about any of your energy usage. The only thing we're going to look at is heating and cooling. And that's what that 7.8% is. And I remember showing this to my partner, who is a business guy, right? I mean, Steve is a builder, but he's also very much a business guy. He's got his degree in business, and he's a partner or an owner in 7 companies, right? So he's very kind of into this stuff. And he looked at this and he said, 7.8%, that's not very good. I said, Steve, where are you going to get a tax-free 7.8% return on your money that's legal in this day, you know? And Dr. Dickey said, you know, if I was building this building and I was going to practice 10 more years and sell my practice, I wouldn't do this. He said, but this is my daughter, right? He said, my daughter's going to own this building for the next 20 or 30 years. This makes perfect sense to me that I'm going to save her $500,000 over the next 30 years or whatever. You know, that's the way we all need to be thinking, right? I mean, we need to be thinking long term. I don't have to preach that to you guys. You guys all know that. So, average, we built 12, this is our 12th dental clinic. That's kind of one of our niches. 12th dental clinic in the last 10 years. When a dentist comes in and sits down with us about building a dental clinic and they say, how much is it going to cost? We tell them you can budget for the building between $150 and $200 a square foot for the building, less site, less your equipment. So that's what we tell them from day one. This was $155 a foot. So the low end of that scale for a building that's saving that kind of money.